I always start with that, with your pictures. I apologize. And then we'll move me over here so that you know I'm here. Okay. I like sometimes where you can see my screen too, and I'm pointing at the screen, and you can see like a double lesson going on here. But all right, so I over explained this last hour as well, and I do like doing that for those that are going to go on and go into calculus and know these little things and can hold a lot of information in their brain about this. Just tell you a little story about Mr. Samuelis. I actually screwed up what complex numbers were, what that word meant when I first started teaching. So here's the boring thing. Natural numbers. Those are counting numbers. That's what the cave people, that's what they started with, counting rocks. They started with 1, 2, 3. Those were just major concepts back in the day. That's why that concept has the term natural numbers to it. Naturally, that's how numbers started. The next subset of numbers is whole numbers. We used to start every year with this and showing these chart of numbers. Whole numbers just add the number 0. Why? 0 is a relatively new concept to human beings. If we talk about, like the number 1, 2, 3, that's probably a million years old. Like, they knew the concept of counting. But the idea of nothingness, is 0 being a thing, was kind of a newer concept. Maybe, I don't know how old that the number 0 is, but relatively speaking, not very old. So it gets its own subset of numbers. Next set is integers. Those are what we deal with mostly, positive and negative numbers. No fractions and decimals. Next subset is rational. Now we're talking about fractions, or numbers that can be expressed as fractions. And then a separate subset is irrational, cannot be expressed as a fraction. You should at least remember these terms and remember hearing these. All of those numbers are real. And that's what I'm going to put as my subset of numbers right here. Everything that I just mentioned, let's call that set right near now. And sometimes they do a double-lined R to represent what real numbers are. Because then there's a whole nother subset of numbers that are not real. Fake? No. They're actually imaginary numbers. And I'm just going to put the number I in there. I said the number I because I is actually a specific variable that represents something. Does anyone know what it is? By the way, what does I represent? Or do we not want to answer questions in the 5th hour? Yes. It is there's a negative involved, but there's a reason for it. All right, now here's what I'm getting at. These two sets together are called the complex set of numbers. I used to think, my story back when I first started back in the 90s, I thought complex meant imaginary. And I thought they were the same set of numbers, and that's not true. Complex numbers are all real and imaginary together in a set of numbers. Right, and then A plus BI. A is the real part of the imaginary number. B is the imaginary part. Don't worry about that too much. That's just usually how we write those. But let's go up here. You said, you gave a guess what I was, and you said just negative. That's all you said, right? But it's actually something very specific. It's a problem in math. It's a thing that doesn't work. And this is what doesn't work. This is what's not evaluatable. The square root of -1. Because what's wrong with the square root of -1? I need a number times itself that equals -1. What's 1 times 1, everybody? What's -1 times -1, everybody? 1. It's an impossibility. This is a mathematical impossibility. So what did somebody do? They said, you know what? Let's just call that something so that we can isolate it and get it out of the way and then be able to deal with the number after that. So for instance, let's don't put this somewhere, put it hiding somewhere. What's the square root of -4? Well, I can't evaluate that. 2 times 2 is 4. -2 times -2 is 4. Doesn't work. But if I do this and I isolate the square root of the negative, then I can do something. Everyone, what's the square root of 4? And then what did you just learn, or you actually learned this before, but just remembered, what do we call the square root of -1? It shall be called what from here on out? I. So actually the square root of -4 is 2i. Now you may think this is stupid or whatever. I'm going to tell you right now, imaginary numbers are why electrical engineers can figure out what they're doing. Imaginary numbers have definite applications to very complicated stuff. So that's just the truth. Real quick question or comment?
So say if it was the square root of like -3, would it just be I times the square root of
Right, and you would probably would write it like that, I root 3. I like that I at first, when you're dealing with radicals. So square root of -3, square root of 3 is not a perfect square, so that would be I root 3. Correct. All right, and that's just to get that I isolated so then you can deal with the numbers. Like, look at this one. So I can at least do something with this number, right? And then later, in complicated math, more things occur. Okay, now here's what we're writing across the boards here. Then what's I squared? And I am taping, right? Good. Hide that. Well, here's what we need to figure out. And I may eventually call on you here, but I'm just going to ask for group responses. Fifth hour, let's see. Square root of 2 times the square root of 2. Square root of 7 times the square root of 7. Square root of 12 times the square root of 12. What do each one of these equal in order? 3, 2, 1. What's the first one equal? 2. What's the second one equal? 7. What's the third one equal? 12. So what do you think the square root of -1 times the square root of -1 equals? Don't take a negative times a negative. What's the answer? This is 2. This is 7. This is 12. This is -1. Free. The square roots cancel each other out, just like the previous 3. So guess what I squared is? Not the square root of -1, a free -1. I just tried to write that 3 times. I love my computer. Big difference. Okay, so now let's take what is I to the third. And this is worth going through. It just shows that I to a power is cyclical. Like some things happen. And really what you should know, and this does make me sad, everyone was mad about chapter P1 with the exponents, but you should know I to the third is I squared times I. Hey everybody, what's I squared equal to? Say it, it's right here. -1. And then what's I? This, but we'll just leave it in terms of I. So I cubed is I squared times I. So it is 1I. Oops. I'm sorry. What's I squared? It's -1. I made a mistake. So this is -I. And my computer not writing is kind of driving me nuts. So I squared is -1. I made a mistake in there. I should have wrote -1 times I. So I cubed ends up being -I. Or negative square root of -1. The negatives don't cancel. They can't mingle with each other inside and out. And then the last thing, what's I to the fourth? I squared times I squared. What's each I squared equal to? Say that number. What's -1 times -1? 1. And then we can go to the calculator, and thank gosh I did type this last hour. I'm just going to scroll up. There is, oh yeah, we're going to be getting students here. But I'm going to scroll up the things that I typed on my calculator and analyze them. Maybe, boy, I picked on a lot of students last hour. Oh, and I forgot. I hit the up arrow like a million times, and this is how bad my computer memory is. I guess it would have been faster if I just did the I's to the power. Okay, 1, 2, 3, 4. There we go. Those are the things that I just did. See that? Now, where's the I on your calculator? It's the period right here. So second I, if you wanted to check this out, that your calculator does this. Now, if I ask an I to a power question, I don't want you to use your calculator. We have to understand that I to the fourth is 1. And then I'm going to raise the powers here. And then I did something crazy. But look at I squared. There it is, a free -1. Look at I cubed, -I. Look at I to the fourth, +1, free, not an I number. It's really weird. I don't know what is done with. I'm not an electrical engineer. I just know every time I talk about I numbers, they have a question sometimes in the book and I know I looked it up. Where do I numbers, imaginary numbers, come into play? And it's amazing how many things it does. Well, look what I did with I to the 11th. Holy crap! What does that mean? After a while, the calculator can't do it anymore. There's like a little mathematical error going on. But really, you should analyze this answer. What is 1e negative 13? What does that mean, scientists? Yes. I'm going to annoy you. You ready? Maybe I annoy you every day. I don't care. Okay? Here's what 1e negative 13 is. It's 0.00000. I've done 5 zeros so far. 0.000000001. The 13th position is 1. What is 0.00000? What is that essentially? What is that so close to it really actually is equal to what? 0. This says 0 minus I. So, where's my pen? Oh, I put it in my pocket. Why did I do that? That was silly. So I'm gonna go to my note thing, and I don't care that oh, there's your pictures again. You can sue me. Nice. So I to the 13th ended up being 0 minus I is basically what that calculator told me. So it's negative I. You got to be able to read a calculator. You got to be able. That's why we teach scientific notation. So how did that actually happen? Because you know what? I to the 13th is I to the 4th times I to the 4th times I to the 4th. 4, 8, 12. Was it I to it wasn't 13th, it was 11th, wasn't it? I'm sorry, my bad. I'm screwed up left and right. Didn't I type I to the 11th on the calculator, right? Everyone with me? My bad, dogs. So I knew something was wrong there. And then I to the 3rd left over. Everybody, what's I to the 4th? That's sitting here on the screen. What's I to the 4th? 1. What's I to the 4th? 1. What's I to the 3rd? Negative I. That's how we got negative I. I to any power is either going to be 1, I, negative 1, or negative I. It's a cyclical thing. All right, so that's kind of explaining the calculator too, and so on. But if you touched your calculator on this to evaluate these things, you're doing the wrong thing anyway. Really, what you'll come to find out, I, when the power is divisible by 4, I to the 20th is 1. I to the 24th is 1. Because all it is I to the 4th, I to the 4th, I to the 4th, I to the 4th, I to the 4th. 1 times 1 times 1 times 1 times 1. That's actually true about I to the 24th. Okay, and then actually questions we're really going to do, like these first two. You know what's great about I, though? It does work like a variable, but it's not a variable. X can be anything from one day to the next. I is the square root of negative 1. Unfortunately, sometimes later in this book, they do use I as a variable, and they shouldn't ever. Why I'm rewriting this is I don't want people to start foiling this. Those parentheses are absolutely positively meaningless. So really, all you're going to do with this question, you should hope there's a million of these on the test on Tuesday, is add them like terms, and you're done. Just know in the back of your mind, I is the square root of negative 1, but we're never going to write it. We're always going to write it in terms of I. Next one, what should I do with the minus sign, everybody? What should I do with the minus sign? Do I have to call on someone? That's it, 5th hour. The line's been drawn in the sand. Second, quit. Do I do that to get out of this stuff? All right, good. Oh, yeah, good. Let's go up here. This is worth it. Sorry, everyone on computer land. What number are you? Oh, no, I'm sorry. Matt, right? What number are you always? 22? Good. Who's going first? Because no one's answering my questions. Hey, student number 5. 1, 2, 3, 4. Jake? What do I do with that minus sign? And then what with it? Starts with a D. DI. DIS. DIST. DISTR. DISTR. I'm starting to figure out, I can't figure out how to spell what? Distributes. You don't just turn the negative into positive and then leave it. You got to distribute it after that. Parentheses are meaningless. What does this become when you add those like terms? And then what does the next thing become? Negative I and negative 3i. Negative 4i. All right, stick with me here, man. All right. Boom shakalaka. Student number 18. Nice. Oh, I don't know who that is. 20, 19, 18, 18, 19. I was never good at math. Is that you? Oh, no. 4, 8, 12, 16, 17, 18. Sorry, that's Nathan. I thought there was 5 in each row. I should put numbers on you guys because that's kind of hard to do. Oh, no. Okay, Nathan. What's the square root of 5? It's a trick question. It's just the square root of 5. What's minus 3i? It's just minus 3i. What's plus? Plus. What's negative 2? Okay, good. What's the square root of negative 9? 3i. That's the correct thing. That's what we got to make sure we do on this. And my fat head is in the way over here in the notes. Let's move Mr. Samuelus. Okay. Why doesn't he just get rid of him? I don't know. And then who are the like terms? What actually happens? There you go. Just like variable land. So you're going to love i's in this sense. They do just work like variables, and they are very easy to deal with. Hey, just to keep going with the fun, first bell didn't even ring yet, did it? I have no idea what I was doing last hour. Malik, it took forever in the notes. Like I don't know what was going on. Okay, square root of 7's nothing. What's I squared, Malik? Not negative I. Negative 1. And then what do we do with this minus sign? So I'll distribute to the negative 6. And then what's the square root of negative 81? 9i. I hope you got rid of that negative, right? Because it's plus, because of the minus negative, and then it's plus 9i. Square root of 81 is 9. The square root of negative is I. All right, and then that's how you break this down. And then I'll take care of it from here, Malik. It's really not a big deal. This is square root of 7 minus 7. That's weird. Plus 9i. You know what, Malik? If they ask you what's the a parts and what's the b part, the a part is that square root of 7 minus 7 part because there's no i's attached to it. And then the b part's the 9. It's kind of weird if they ask you that, but really we were just simplifying so you don't need those parentheses. Ain't no thing. I wish on the homework I had more of these kind of questions, square root of negatives, and then getting the I out and then simplifying after that. Kind of missed that calling. It's all right. It's mostly these operations and my next one. I'm not even showing you that. We're just jumping to it. Boom. And don't worry about that being number 12. I just pulled 12 out of a book that we have. Boom. Good. First bell. Nice. Mitchell, you ready? Did your teacher use that 4-letter F word for these kind of questions? What is that word? Foil. So what's first? What do you get when you do this? Just do it like you were in Algebra 1. You do get 10i squared. But now this is Algebra 2. We'll get that later. What's this one? What's this one? Don't know why people can't FOIL. What's this one? One of the simplest processes ever, and then it actually helps with factoring when we have problems like that. But here's the difference, Mitchell. What does 10i squared become? It is just negative 10. And that's what happens. That's the difference with I compared to x, just a random variable. You do nothing if it was 10x squared. You just add the middle term and you'd be done. Well, I squared is actually equal to negative 1, and we need to evaluate it. Okay? All right, so that's the point of that one. And I'll take a second here. Let me get another student while you're writing. Boom. Nice, and we'll figure out who that is. Hey, nice, Matthew. Okay, here we go. Matthew, what's the square root of negative 4? This is not a FOIL. What's 2i plus I? So this is actually what word would describe what you do in this one? It is a distribute. What's the first distribution? What do you end up getting? And then what's the second distribution? And then because I is special, what's negative 15i squared become? It is. And you know what I'm going to do? I'm going to write it in front. I'm going to write it in an A plus BI format. It's not mandatory. Boy, that'd be a really jerk math teacher if they marked you wrong for writing, this 18i plus 15. I said it. Someone got like picky about that. Okay, and then here's the last thing, and I'm not going to let you write all this down, but can everyone say conjugate? Nice. They actually said it. Did you hear that? So here's what you have to do. I'll show you the directions on this. I don't, we have seen this before. This is definitely not any student's favorite. Like over the years, this is like one of the worst things students do. It has nothing to do with COVID or not, and whatever happened last year or the year before. Baloney. All right. It is something that students just don't like. Okay. Now I'm going to do the first one. Just implore that you follow along, and then the student I choose is the next one. We'll do it. This is the complex conjugate of 3 minus I. And the reason it's special, well, here's the problem, by the way. This is a radical, and it is in the denominator, and that is not allowed in math. You cannot have a radical in the denominator, right? I mean, that's one of those stupid rules. I'm with you. All right, but I was working with a calculus student in tutoring, and they were doing rationalizing a denominator, but it was like a monster, and it took like 6, 7, 8 steps. It was brutal, but we got through it. So the idea of what you need to do to rationalize is a concept, knowing the conjugate idea and why this works. Let's first look at the bottom. This is the only time I'm going to write this, the full foiling. 9. This is the whole point of the conjugate, 3i, negative 3i. What happens to that middle term, everybody? It cancels. This is the power of the conjugate. All right, so I will never write that again. Next question, I refuse. Negative I squared. All right, and then up in the numerator, you probably do want to distribute. Actually, I probably shouldn't because I know what happens with this. I really should not have distributed because I can't cancel a part of a binomial with something else. Anywho, we should know at this point that that's positive 1. 9 plus 1 is 10. That is 1. This is minus negative 1, minus negative 1, which makes this a free 1. This is positive 1. Don't rewrite the whole thing. Oh, okay, I don't get it. This is this is minus I squared is a free negative 1. So that's why this becomes 9 minus negative 1, which is 10. And then actually I should not have distributed that too. I really shouldn't have. So I'm going to backtrack on that. And then I could cancel these, and this becomes 3 plus I over 5. That is mandatory, by the way, that you do reduce this fraction at the end. Not optional. So shouldn't have distributed it too, so that I can cancel correctly at the end. Matthew, were you up? Did you do something? Yeah, you did do something. Okay. Boom, 3. Nice. That's a new one. Kathleen? Kathleen, I feel like the calculator gets you a lot. Don't you agree with that? No? I thought you go a lot. What's the conjugate? Go ahead and loud and proud so I can hear you. We're going to multiply top and bottom by 2 plus 3i. Project that voice more. 2 plus 3i. All right. And then I'll do your multiplying and just ask you some pointed questions here. By the way, why top and bottom? This is equal to 1. I'm just putting that up here as an idea. I've multiplied this by 1. So I haven't changed its value. I'll FOIL up here and I'll just ask you some questions. 5 times 2 is 10. 5 times 3i is 15i. I times 2 is 2i. I times 3i is 3i squared. I am not showing the middle term. We should know what happens with the middle term. It cancels. This is the point of the conjugate. This is the point of plus minus. Middle term falls out. I already forgot. Kathleen, what's minus 9i squared? What does that become? Let's break it down. What's I squared? What number is I squared? What kind of one? You got to speak up. What? scream, man, like you're yelling at me. Roar! -1. And then what's -1 times -9? What happens to the two negatives? So 9 plus 4 is what? What's 4 plus 9 now? 13. And then on top, what's 3i squared become? We'll write that right above that. What's 3i squared become? -3, I think I heard. And then what's -3 plus 10? 7. And then plus 17i, I went ahead and added these as like terms. Okay? This is how you kind of bounce around a question and simplify it, not write more steps than you need to. Kathleen, lucky for you and anyone else doing this question, this doesn't simplify. All those numbers are prime, so I can't factor and cancel. All right? Is everything okay? -3 plus 10.
Oh, okay.
7. Okay, so that's kind of, I'm trying to help myself get this done a little bit more quick, without having to rewrite steps. So I know I kind of get messy with the notes there and do that. I kind of do this. 3i squared is -3. I kind of like do that evaluation right there, and that's okay. All right, now I hope we're okay. I'm not doing that one. That we're able to move on to this. I will tell you that this is going to be a big chapter 2 concept as well. We're really going to re-break this down. But on the test Tuesday, we are going to probably throw a couple of quadratics and see if you can solve those pretty quick. Because we know in Math 3, quadratics are like way overdone. You do quadratics and graphing them and parabolas and analyzing the graphs and then factoring and then solving by factoring and then solving through the quadratic formula. I will tell you right now that we're not going to solve by completing the square, so I'm going to get rid of that. The process of completing the square will come up in November and December, though. There is a usefulness to this. We try to break down the CAT class into, when is it useful to use this process, and then that's when we'll teach it to try to keep things, really focused on particular things per unit. Now, it really depends upon the question. If it's factorable, good factors get tests done quicker. All right. For some reason, this is a lost art with my CAT students. Throughout the years, some students still can't factor by December. They don't get it because we have to factor like almost every week in here. Sometimes the question, you should do it by extracting square roots. It depends how the question's given. If the question is not factorable, then we are going to have to talk about the quadratic formula. And quite honestly, in Math 2 right now, next chapter, we're talking about the quadratic formula. So I know that it's something that you've seen probably the last 2 years. All right, so let's take specific questions like this first one. I'm going to ask you some pointed questions, and I know that was day 2 of our notes, I think was the factoring. Nice. We're getting almost everyone in that first row. Jennifer, I'll help you out on this. But why is it a quadratic? You have an x squared. I don't know why it's called quadratic, but that's what they're called. You don't want to do what you did with simple solving. You don't want to try to get everything over there. I got an x squared and an x. What you want to do is pull the 15 across. And this is the fast and efficient math student. Can I factor this? And Jennifer, I'm telling you that you can. And here's the analysis for this factoring. When you have a trinomial, 3 terms, and the leading coefficient's 1, then it's a simple MA. Jennifer, what multiplies the 15 and those same 2 numbers added together equal -8? And guess what? Those 2 numbers you just said are what's inserted into these parentheses as 2 binomials. Because good FOILers, remember I said this, good FOILers are good factors. Hey everybody, what's x times x? X squared. Hey everybody, what's -5 times -3? Positive 15. And then look at the middle term. What's -3x and -5x? We know this is the correct factorization because when I multiply, I get the question. Now I use what's called ZPP. Zero product property says if this times this equals 0, then either this equals 0 or that equals 0. That's the only way that this could be true. And then you solve each factor. X equals 5, x equals 3. And then remember, for solving, I'll bore you. Take that 5 and plug it in. 5 squared is 25. 5 times 8 is 40. Hey, take a guess what 25 minus 40 is. Everyone say this number. True. 3 squared is 9. 3 times 8 is 24. Take a guess what 9 minus 24 is. Negative 15. True. That's why these are the solutions. Now, honestly, I am going to show you the quadratic formula. For maybe survival, you might want to use the quadratic formula to solve this. But it is factorable. There is no 20 product property. I'm going to write this down, and then I'm going to cross it off so quick your head will be spinning. Any student that ever does this, you're making up a math. That is not true. And as a matter of fact, the two answers you get, we already see x equals 20. I plug in 20 and 20. This doesn't equal 20 as a product. That's mathematically incorrect. What you need to do is get the zero product property going. So you need to distribute, actually, then subtract 20, and then try to factor if you can. This is why maybe the quadratic formula if you're really bad at factoring. But you know what? Whoever's number comes up, I'm going to make you factor this. Boom, 4, 8, 12. Julia, are you back there? Julia, don't sweat it. I'll get this going for you. You definitely have to get the first two blanks right, though, because all I'm going to ask you is, what times what equals 3x squared? There's only one possible thing that could happen. Got to be whole numbers, integers. What times what equals 3x squared? Or you need an x and an x. So at least I hope you know that this has got to be, we got to bust up the x's. So I like the 3 and the 1, but one of them's got to be a 3x, the other one's got to be a 1x. Because good FOILers, good factors, 3x squared. Now, what are some things that equal negative 20 when you have a product? Let's stick with that one. Doesn't one of them have to be negative? Guess and check. Who do you want here? Do you want the 4 or the 5? You want to put the 5 here? You want to put the 4 here? Who do you want negative? Okay, now watch what happens. That's good. Did you get the correct middle term? What's 3x times 4? What's 3 times 4? 12x. What's negative 5 times 1? What's 12 plus negative 5? Is it 11? You know what you got to do? You're close. Trial and error. What are you actually going to put in the first blank? The 4. And then what in the second blank? This is the magic of factoring, man. People that get a process and try to just memorize a process don't understand what they're doing to express an answer that is sensible. See, this whole process of knowing that this has got to be 3x squared, this has got to be negative 20, and then getting the middle term could be a guess and check. This is how I have my honors students do. By the way, do you feel good about this answer? 15x and negative 4x is 11x. Okay? And then I could use the zero product property after that. So there's factoring 101. I really want people to be unfoilers the best they can. I did show a trick on this, and we'll cover factoring so much this year that we'll show that later. Real quick, what should I do with this question and this one? Let's start with this one. You should not use the quadratic formula. You should not factor. This is perfectly set up for extracting square roots. What is the opposite operation of squaring? Square rooting both sides. This is the most efficient, fast way of doing this specifically worded question. Going right to that. So here's the problem though. Watch what the book shows. Boom, what's in front of the 3 for the square root of 9? Plus or minus. And you know the reason? Because. That is actually the reason. It really is because of this. Tell me what solves this equation, x squared equals 4. What number squared equals 4? 2, right? What other number, though? Negative 2. Just by default, both the positive and negative solve this equation. So we must understand and remember that. So therefore, we must put a plus minus in front of this because it does satisfy both of those parts. Then you go ahead and separate this into two separate scenarios and solve. So specifically, when you have like a parenthesis squared, square root both sides, just don't forget the plus minus. And then you end up getting something that works out pretty well. Where are we at on time? Don't we get out at 55 or 50? 55. Thank the maker. If there is one in the public school, sorry. Just something C3PO says, so Star Wars quote. Real quick on this one. What do you think you're going to do first? Student number 2. Nice. Jennifer, calculator loving you today. Do you think I should square root first, or do you think I should do something with that 4? Nice. You know what I'm not going to do, Jennifer, because I see the future. I'm not going to simplify that 18 over 4 yet. And I'll tell you why. And then what are you going to do, Jennifer? Exactly like the last question. I'm going to do what to both sides? Square root. Now you might know why I didn't simplify. Look at the bottom. What's the square root of 4? 2. Now let's look at the top. What's 18? What times what? What's the square root of 9? So hopefully you can handle that I write this. X plus 1 equals square root of 9 is 3, root 2, over square root of 4 is a free 2. What didn't I write though, Jennifer? I'm pointing to it right now. Plus or minus. And then all you have to do to solve for this is subtract 1. And really what you should do is put that 1 there. And then don't worry about getting a common denominator. That's actually the true answer for this polynomial with a radical answer. Hey, what if that was negative 18? What if that was negative 18 over 4? Just what would be in there? What letter? What letter? What letter? I. So that's how we can get I numbers with square rooting both sides. And then I'm going to end with this. And I know this is full, but hey, we got 2 days of review. Here's the quadratic formula. You ever have a teacher sing the quadratic formula to you? Huh? Anyone have a teacher sing it before? What? I don't know how to read, you guys. Fifth hour always just looks at me, no one answers questions. Goes the pop, goes the weasel. Maybe we'll wait till later and sing that when we have chapter 2 happen. But you know what? Prerequisite chapter, we're just seeing, can you remember this? And when do you use it? Well, we could have used it on that one, the 3x squared one, if you're not a good factorer. If you would have done the quadratic formula, you would have got those 2 answers, as long as you know how to simplify. But usually it's only when we're unfactorable. And we do have situations where that occurs. And I'm only going to do one example of this, inserting the numbers into the quadratic formula. And then you'll see why this is in this section. I started with I numbers. Well, you can get I numbers for solutions of quadratics. All right, and we do, and hopefully remember that. So the opposite of b plus or minus b squared minus 4ac square root of, all over 2a. And then let's get my student as we're writing down that last part. 19. Oh, who almost made it? 20, 21, 22, 19. Samantha? She looks sad. Hey, Samantha, is there a number that, 2 numbers that multiply to 5 and at the same time add to 2? No, it's like, what multiplies to 5? 1 and 5, right? What's 1 plus 5? This is not factorable. So for me to solve this, I have to use the glory and power of the quadratic formula. I'll go ahead and fill the parts. Since this is not factorable, I just want you to understand that that's A, that's B, that's C. So the opposite of B is the opposite of 2. Don't put X with it. I get some goofy students doing that. There is a reason why the quadratic formula works. We got to move on. We just got to accept that it exists in this class. Then b squared, which is 2 squared, minus 4ac all over 2a. All right, what's 4 times 5? Samantha? What's 4 times 5? And then what's 4 minus 20? Positive or negative? And then what's 4 minus, or 20 minus 4? That's all you have to think about it reversed. 20 minus 4, use your fingers. 20 minus 4, 19, 18, 17, 16. And then in what we're doing today, what's the square root of negative 16 become? 4i. And there we go. We have an I number as a solution for a quadratic. So that's the only point of inserting that in. We could have used the quadratic formula before and got real numbers. Sometimes you get I numbers. By the way, can I cancel these 2's? Yes or no, everybody? Can I do that way? Yes or no? No! Okay, what you got to do is cancel or factor out a 2. And then you're left with negative 1 plus or minus 2i. And then cancel the 2's. And then you have a nice negative 1 plus or minus 2i answer. That's how you do it. All right? All right, so now you see why that's inserted into this. You guys grabbed your worksheet, right? You can see the first 10 questions are just I numbers. The second 10 questions are quadratics. The first 2 quadratics literally say solve by extracting square roots. All right, so you want to do the square roots of both sides. Then the last section, you choose your method. I don't think 13 is factorable. I don't think 14 is factorable because 23 is prime. So 13, 14 are probably quadratic formulas. I think 15 is factorable, 16 is factorable, 17 is definitely factorable. And I don't know about 18. I can't think about that one right now. 30. Yeah, I don't think 18 is factorable either. Oh yeah, solve each equation with the quadratic formula. I would say solve each equation using the best method possible. I wouldn't do quadratic formula. I would really want you to factor 16. You definitely want to factor 17. Put factor next to 16, factor next to 17. For sure. I gave you multiple choice, 1 and 2. Remember I told you? I to a power is either 1, I, negative 1, or negative I. That's why you have the 4 choices there. I did that on purpose. Oh, we're still taping. Great. As I roam around the room.